Hello guys, we are going to be coding today. I have started out from the basics again. I am learning C++ and I realized that my strings were weak in C++, so I have just opened up these sets of questions and I'm just randomly solving them. I have solved till about this 11th question by now. In this one we had to find the word in the string that has the most number of repeated letters. So most number of individual repeated letters. For example, uh, in this case, the answer is separate because E is repeating two times and A is also repeating two times in this. So I have solved this one by now. You can also try solving it. I will show you my solution now. So what I have done is I'm using the find function to find the spaces, and whenever it hits n pose, which is basically the end of the string, then I just stop the while loop and I get the current word using sub-str, getting the substring from the starting position to the along with the length, which is post minus start. And then for the current word, I just use the count function from STL, and using this count function I just find the characters that whose count is greater than 1. Then I just save them in this map, and if the size of the map is greater than highest frequency, this variable, name it anything you want, then you just update this variable and update the current word as well, which is the word with the most number of repeated letters. And then you can just clear off the map. You can update the start variable to position ahead of pose, and then you can find the new space, the new position of that space from ahead of that. Then the same code after the end pose, we just come out, repeat the same thing again because the last word is still left to be processed after this. So I just process it again and just uh, uh, print out the word. So let us try out some input letters in this. An input sentence, basically this one. Let's see this. It gives us separate. Let us see some other examples that we can use. I don't know what kind of code they use, but it is really long. Maybe theirs is more efficient than mine. But I'm practicing strings, so I'm specifically adhering to using string functions, or basically the inbuilt STL functions, because I'm practicing the language from scratch. So you can do it any way you want. Let us copy this, paste it. Just a second. Sorry, I did not run. Second. Not name a type. Sorry, my bad. It gives us characters, fine. In this case, it will give me 0 because I have not updated it to return -1, but it will be the same thing. Just a second, let me start in the code. Yeah, it printed out nothing, basically 0 in this case. So yeah, because none of these have any repeated characters, that's why it printed out nothing. So for the next questions, I am going to be staying quiet. For the most of it, I will be solving it myself. Vibe coding or whatever you want to call it, you can try solving them yourself as well. And in the end, I will share my solution if it works. So that is it. Now I am going to go quiet. Okay, so I have solved this question. Uh, a place where I was getting stuck in this is I was not accounting for the size of the string being increased whenever I add a new character in it. So once I did that, it worked completely fine, basically accounting for the dash and the next character as well. So when you and yeah, this is how you solve this question. Just convert the current character to an integer, then use the modulus function to with 2 to check whether it is even or odd. If both the current character and the previous one are odd, then you just add a dash in between them. That is it. So whenever you add a new character or insert a new character, make sure that you move ahead by one position, so that you do not get stuck in an infinite loop accidentally. As for the edge cases, I am not writing specific code for like error handling in this case. You can do that yourself if you want to. For example, if the character is like non-numeric or anything like that. So yeah, you can do that yourself. Now we can move on to the next question. So yeah, this code was very simple. We had to just convert each character. If it was uppercase, we had to convert it to lowercase, and if it was lowercase, we had to convert it to uppercase. Very simple code. You just check if a character is uppercase, then you convert it to lowercase. Otherwise, if it is lowercase, then you convert it to uppercase. Make sure to use an else statement in this case, because for example, if you are converting it to lowercase and then again in the next if condition, if you are checking if it is lowercase, then it will come out as true. Or you can just also add like a continue statement after it. The choice is yours, but do it either way you want. Now we can just move on to the next question. Do try it yourself as well. And yeah. Okay, for this next question, which is sum of numbers in a string, I don't know what they have done in the sample input and output, but according to what I have understood, the question requires you to find all the numbers in a string and then return the sum of all of these numbers. So technically, the output of this one should be like 3 plus 2 plus 8, which is 13, or yeah, 3 plus 2 plus 8, which should be 13. I don't know what they have done here. Their sample output is 2011. I don't know how that works. I've also checked, like, I've also clicked this link to see some sample inputs, and we can also see in the visual representation they are just taking the sum of these numbers, and this is what we have to return. But in the sample output 91 ABC Street, they are returning straight up 91. In this case, they are returning 2011, and for this one, C++ version 14A1123. I don't know how accurate this one is, but I don't think it is accurate. Like 1 plus 4 5 plus 2 7 plus 5 should be 12. This is 48. So that doesn't make sense, but If their visual representation is correct, then our code and understanding of the question should be correct. So what I've done in this case is I've just checked if a character is between 0 and 9, the ASCII value, and if it is, then I'm just subtracting 0 from it to convert it to an integer and just adding it up in this sum, and then I'm just outputting out that sum. So that is quite simple. Now we can move on to the next question. You can also try that out. Hello guys, so welcome back. I had to leave. I had to go somewhere, so I wasn't able to finish the question. But I then started solving it and completed it quite a bit. So I will just tell you how I solved it. Since in this question it was not mentioned like till what value we're going to be going, I first solved it for like till 100. It is quite easy to solve it till 100. So what I'm doing is I'm taking the integer string and converting it to an integer using stui function, and I send it to another function. For now, don't worry about this. Let me replace it with below 100. So this function converts the number to integer when it is like below 100. So let me show you the output. For example, 10, it will just give me 10 directly. I can write anything I want. 42, 99, but it won't work with 100. So this is below 100, this specific function. First, I will tell you how this works. So I have an array in this. This is like the hard-coded bit, you can kind of call it. So if the number is below 0, then I just return the result because the question asks us to convert non-negative numbers. So, and when it is below 20, then it is kind of hard-coded till like 0 till about 19. So yeah, and when the number is below 100, what I'm doing is I'm just taking the modulus of this, or you can say the remainder, which give me the ones place digit, and then I can just add the result from like till 20. This is for the ones place digit, so I will get, if it is not 0, so if it is not 0, I will get something like from 1 till 9 I would get. So I would add this to the result, then I will divide the number by 10 so that I can get the tens place digit. And if the number result is not empty by now, I will add it to the result, and within with a space I will add the previous result to it as well, so I can get a number like 42 in the space. And if the ones place digit is 0, then I don't need something like 40 or anything, so I will just add 40 to it, which is 20 to 100, and just return the result. Similarly, what I've done for 100 is like I've kept this array till 20, and what I'm doing is I'm dividing it by 100 this time, and if it is not 0, for example, if I'm dividing it by 100, I will be getting these two digits, right? So these two digits, if they are not 0, then what I can do is I can call this function solve below 100, and it will give me the result for these two digits, and then I will go to this digit by dividing it by 100 if it is not 0, and if the result is not empty, then in that case what I can do is I can just a second, I need to edit this just a little bit. Yeah, so if it is not 0, this digit, then it means that we are in the hundreds right now. So if the result is not empty, I just add the current number that's supposed to be, for example, this would be 100. So this digit would come from this till 20, from 1 to 9, and then I can just take this 1 to 9. I can then add 100 in front of it and add the result. If the result is empty, then I just don't add the previous result in it. Similarly, for 1000, I just divide it by 1000 and repeat the same process with it. The only difference in this case is going to be is that if the number is not 0 and if it is below 20, then what I do, I just directly add this result in it. You can also add the condition for like if the result is not empty. I have not done it yet because I'm solving till thousands below million. So when whenever if the number is below 20, then I will just call this till 20 function and add it to this. But if it is greater than this 20, then we will have to use the solve hundreds function for it. So what I am going to do in that case is I am just going to solve hundreds plus 1000 plus result and add it to the result. That should give me the output correctly. Oh, now that I think about it, if it is even below 20, I can still just solve 100 and add it to it. Let me just try it out for a second. Like this, right? Oh, just a second, I have to change this first. Solve thousands. For example, if I go with 10,000, I will get 10,000 correctly. If I go with something like 19,000, I will get 19,000 correctly. If I go with something like 42,000, I will get 42,000 correctly. If I was to go with 100,000, it gives me 100,000 correct. And let me go with the highest value possible, 9999. Yeah, so 999,999. Yeah, so this is correct. I don't need this piece of code, only this condition if it is not 0. I will keep that, delete everything else, keep this, let me delete this. This should work completely fine. Similarly, we can go up to like about a million or a billion or something, and the code will be exactly same as this. Just for million you will be dividing by a million and changing this solve hundreds to thousands. Simple as that. For example, I will just show you, why not, for the million. So string solve millions and num. Let me copy this piece of code. We paste it here. This remains the same. I will convert it to a million, which is 1,000, 10,000, 100,000, million. Let me call this will be like in 100,000, right? Let me call this thousands. Thousands, this will become thousands. This should also be a million. And then here as well we will go with thousands, and instead of 1,000 here I can just go with about a million. This should work. Let us try it out. Let me first check if the previous code is working correctly. Oh yeah, I have to replace this as well. Millions. $999,999. This works. Let me check for like a million. 1,000, 100,000, million. 1 million. Now let me go higher. Completely random number in millions. But let me just check it here, to be honest. They might have some kind of output, right? This is... Let me test out with this first. This is 876,543. 876,543. This works. Okay. Now let me check for like about a million. Okay, this should be 8,734,210. 8,734,210. Yeah, so this works as well. And let me go till about the highest, 329,000. Yeah, this should work. Oh, sorry, I have to run it first. This should work. 329,876,120. 329,876,120. So this works. Similarly, I can go for like about a billion. Since we are already on it, why don't I just write the code for it as well? This should be simple enough. String solve billions. Similarly, just copy this piece of code. What we are going to be doing right now is, instead of a million, 10 million, 100 million, billion, we will be dividing it by a billion. Similarly here we will be dividing it by a billion. Just quickly go there, and instead of thousands, let me make this millions. These two, let me make these millions as well, and this will become a billion. And now that I realize I don't need this vector in this case, I can just remove this. Similarly here, I don't think we are using it anywhere in this function here, so I can just like remove this, not needed. Similarly here, we are not using it anywhere. Let me just remove this quickly. So yeah, now this billions code, billion, we are solving with millions. We are dividing by a billion and result in billions. Yeah, let me go with billions. So this should work. Let me start with something smaller. This same thing. Come on, man. Copy this first. Let us play. 329,876,120. This works. Let us check it for a billion now. Second. Damn, this is a really big number. I don't think this would even fit because we are using integers, not longs, but I will have to see. Sorry. Yep, does not work, out of range. I think we should just convert this to long int in that case. Similarly for all of these, this specifically, to be honest, long int. Yeah, so this should work this time around. Where this? Let me copy this again. STOI out of range. I'll have to check this. I think there might be another function to convert this to a string, or I will have to change it accordingly. Okay, there is a function called STOL. I never knew that. 9 quintillion. Is it larger than 9 quintillion? I thought it was in billions. What? It is 1 billion, it says. Okay, there is a mistake. They have made a mistake in this case. I can see that now. Yeah, there is a mistake in this, clearly. Wrong input in their case. Let me just quickly get this. I never knew there was a function called STOLL. Let me try this out quickly. So there was a mistake by their part. Let us run the code again. I will just try to go for about 999 billion. 999, 99,000, 3 more, and then 3 more. Yeah, so this works. 999 billion, 999 million, 999,999. This works completely fine. So this should work. And yeah, this is good. Let me just save this piece of code quickly. Save as. Number 2 words. By the way, just so you guys know, you don't have to do it the way I did. I did it like this because I am familiar with converting till about 100. So I started out with that, and then from there I wrote the function that solves for greater than 100. Then I created the function that solves for greater than 1000. Then I created the function that solves for greater than million, and then similarly billion. You don't necessarily need to do it like that. I just did it because I was moving step by step kind of. Other solutions, for example, like their solution in this case, they have a separate function for converting number to 100. Like if it is below 100, they have a separate function for that, and then just keep dividing it by 1000 and keep getting 3 digits, because from what I know, like you divide it in like 3 by 3. For example, you go 100, then for 1000, what you will do it, you will be using 1 comma, and then it will be written as 1000. So you have 3 digits in this case. Similarly, if you go till about 100,000, but if you go for like a million, then it is again divided by a comma. So it is using 3 digits each case. So you can just write a function for this accordingly. Like you can use a loop divided by 1000 each time, get these 3 digits, solve for them. Then the next one, add 1000 in front of it. Next one, add a million in front of it. Next one, add a billion in front of it. That should also work. Simple enough. So yeah, now we can just move on to the next question quickly. You can also start solving it with me, and I will be going quiet now. So yeah, just start solving it now. So we have solved this question as well. This was very simple. We just had to find the longest common prefix for an array. So the prefix is the starting part, the very start of the array. So we just need to find the common start of different strings in an array. For example, this one we have padas, packed, pays, pacha, whatever the hell this is. So in this, as we can see, the most common prefix in all of these is pa. After pa, we can see it changes because of this first one to d. So the longest common prefix is pa. So for this solution, what I did, I just created a string, inputted all of these values in the string, and in the vector, I created a vector of strings, inputted all of these different strings in this vector. Then I call this function called solution. In this, I'm doing nothing. If the array size is 0, then obviously there is nothing in there, so we can just return an empty string. If there is just one element, obviously it is common with itself, we can just return it directly. And then I'm creating a variable called prefix. I am assigning the first value of this array, the first element of this array, to this prefix, and then from the next element onwards, what I'm doing is I am using the find function to see if this current prefix that I have exists in the current element of the array as a prefix. So I find the position of that prefix if that position is not equals to 0. If it doesn't exist, it would be n pos, and if it does exist and it is not 0, then it will not be getting into the while loop. And so if the position is not 0, then in that case what we can do is we can take this prefix or substring. We can take the substring of this prefix, basically breaking it up one by one. First I remove this this last character, then this character, then this character, one by one. And if the prefix becomes empty, we can just return the empty string, and if it is not, we just check it again. If it is not 0, then it again goes into the while loop and continues. So that's it. This is the solution for this one. Now we can move on to the next question, and you can start solving this one as well. Okay, so I have solved this question as well. It turned out to be a bit more difficult than I expected. In this question, what we had to do is we had to find all possible combinations of well-formed brackets from a given pair of parentheses. So, by well-formed bracket, it means that for every opening bracket, there is a closing bracket. Then it becomes a well-formed bracket. So, uh, in this case, for example, if we have two separate brackets, there can be two closing brackets and two opening brackets. So these are the two possibilities of well-formed brackets. Basically, there is no issue in this. It is a valid pair of brackets, or you can say a valid combination of brackets, whatever you want to call it. So the first solution that I thought of in this case is to get like all possible permutations of the brackets, and then check for each one if it is a valid uh, bracket permutation or not, valid parenthesis or not. I could have used used that, but it would have become like an n factorial solution, so that would not have been good. So I just like dug around a little bit. I wasn't expecting it to be a backtracking question, although I was kind of, because the second solution that came into my mind was to use tags, but I just was not expecting it to be like this. I was just expecting a simple string question. So now I will tell you how I solved this. First, I wanted to know like what should be the condition uh, for this, basically, like what should be the condition so that I can start solving this question using backtracking or stacks or anything like that, because I was a bit confused by that. So the condition that I found after researching a little bit is that the number of opening brackets, uh, for example, when we are like placing the brackets in the string, then the number of brackets that we are placing is decreasing. So we have two kinds of brackets, opening brackets and closing brackets. So the condition that matters in this case is that basically the number of opening brackets should always be less than the number of closing brackets, less than equal to, basically. If the number of closing brackets is becoming less than the number of opening brackets, or you can say that we have added more closing brackets in our string than we have added opening brackets by now, then in that case it would become an invalid string, or invalid combination of well formed brackets. Uh, because, like, let me show it to you. What was it? This one. This one is it. Yeah. So, for example, if we have like a single bracket, then we have these two possible combinations. Now the second one is invalid because, as you can see, for this opening bracket there is no closing bracket, and for this closing bracket there is no opening bracket, right? The valid is going to be like this. So now let me add one more, and we can see it gets kind of all over the place. So you have these, this is a valid pair, this is an invalid pair because we have a closing bracket then an opening bracket, and there is no closing bracket for this one, there is no opening bracket for this one. Similarly, other cases as well, these cases. So what we see from these cases is that, like, for the invalid pairs we can see there is one opening bracket then two closing brackets. So there is just one opening bracket and two closing brackets, so there is more number of closing brackets than opening brackets. It automatically becomes invalid in that case. So that is the only thing we had to keep in mind. Then I just started with recursion. I had this array that I created, I send it to this function, and the number of opening and closing brackets as well, and the current string that we will be appending to this array if it is valid. So the base case is going to be if number of opening brackets becomes 0, is it can be both, like number of opening brackets become 0 and closing brackets become 0, but in this case you don't have to worry about it. If number of opening brackets is 0, then we just append the rest of the closing brackets to this current string. Now that can also be 0, so 0 closing brackets appended, you don't have to worry about that. Then you just push this current string to the array and then you return from this function. The next condition that was the most important condition for us is that the number of closing brackets that we currently have, that we have not put in the string, should always be less than the number of opening brackets that we currently have. So if the number of closing brackets become less than the number of opening brackets, then that is an invalid case. We can just directly return from that. And otherwise we have two possibilities. You either add an opening bracket or you either add a closing bracket. So these are the two possibilities, and using this recursive solution we just implemented it. Works completely fine. Let me just show you that. So if we have two elements, then this is the valid pair of parentheses, as you can see in this as well. If we have 3, this is the valid pair of parentheses. We can see there is no invalid pair in this case. We can also try 4 with 4. Now this is pretty long, but I don't see any invalid pair in this case. So yeah, this was the solution for this. The question definitely turned out to be more difficult than expected. I wasn't expecting a backtracking question in this. I thought these would all just be basic string questions, but if you find it difficult and you are just starting out from the basics, just don't worry about it that much right now. Focus on other questions, other string questions. Now we can just move on to the next one. Now I will be going quiet again. You just try solving the next question yourself, and yeah. So guys, I have solved this question as well. I made a mistake at the start. I thought I had to just find like uh, the number of valid parentheses or something, but note that I had to find the length of the longest valid parenthesis substring. So what I did for that is like the longest substring, for example, in this case is if you go from this to this, like this last bracket and the first bracket, the length of this is going to be 2. In this case, the biggest one is going to be 4, as we can see the first one and the last one. So the length in this case is 4, and in this case, the length is 0 because there is no valid parenthesis substring that you can make. So what I did for this one is I took an open stack and a closed stack. You can also take vectors, it would not really matter one bit. And then I started a for loop. If it is an open bracket, I just pushed it in the open bracket. If it was a closing bracket, that means that there is a possibility that we have found a valid parenthesis, right? Now, for the valid parenthesis, first of all, the opening bracket stack should not be empty. Obviously, only then we have a valid parenthesis. And if it is not empty, then what we can do is we can like check the length of the opening bracket parenthesis stack and the closing bracket stack. So if we combine the length of these two, then that can give us the length of the current longest valid parenthesis. And if that length is bigger than length, then you can just update it, add it, and you're good to go. Of course, in this case, we are not popping anything, so I don't even need this condition exactly because the length is always going to be increasing. Technically, it won't be able to decrease. So if I just remove this condition and like let us see once again, if I remove this condition and run the code again, it should work just fine. And also let me tell you that once I have calculated this length of the longest parenthesis, I just push the closing bracket into it. So let us start by checking if this works. 2 works completely fine. This should give us 4. This works fine, and this should give us 0. So this solution works completely fine. You can use it as well if you want. This is it. This is the piece of code for this simple question, simple solution. Now we can move on to the next one. You can also try this yourself. I will become quiet now. Okay, so we have solved this question as well. In this one, we had to reverse only the vowels in a string. So, only the corresponding A, E, I, O, U. Wherever you find them, just reverse them. Uh, Basically, the way you might reverse a normal string, you might already know that what you do, you can use a two-pointer approach. The last pointer, first pointer, replace these two characters, update, and go backwards, replace these two, update, go backwards. You do that until your starting index becomes greater than your ending index. I use the same application here. I just used a two-pointer approach, created this function to check if it is a vowel or not. And using the two-pointer approach, if the while loop continues until start is less than end, and basically until start becomes greater than end, that's when we stop the while loop. And the first condition that we are going to be checking, if both s of start and s of end, if both of them are vowels, then you just replace them with each other. uh, Increase start by 1, decrease end by 1, and continue. And if both of them are not vowels, then what you will do is you will check if start is not a vowel, then you will increase start. If end is not a vowel, you will increase end, and that is it. And you can just print them out. Very simple solution, very simple question. We can move on to the next one now. 20th, you can try it out yourself. I will become quiet again. Okay, guys, I have solved this question as well, in which we had to find the length of the longest palindrome in a string. I have used a simple solution in which I expand around the center of each, basically the each element of the string or each character. I expand around it as a center. This is the code for odd length palindrome, in which in this I just set the starting and ending position same as I, and the current length as 1. Since we are at the same position, the current length will always be 1. This current length is the length of the current palindrome. And I just update start and end and check the conditions. If they are in bounds and if they are equal, then I update the current length by 2 and just update start and end. And in the end, I just check if current length is greater than longest length, and I just assign longest length as current length. Similarly, for even case, in this case the only difference is that start is I and end is I plus 1. The loop is only until n minus 1, and current length is going to be 0 if the characters are unequal, and if inside condition is completely same. If they are equal, then update the length by 2, update start and end, and in the end check if it is greater than longest length and update. So this is an O of n square solution. Even the dynamic programming solution of this question is O of n square. So I found another solution to this, which was O of n. It is called Manicher's algorithm, I guess. It uses the previous calculated length of the palindrome to find the length of the palindromes later. So it is an O of n algorithm. You can check it out and apply it yourself if you want to. I'm feeling a bit lazy, so I'm not doing that. I'll just move on to the next question now. Okay, so I've solved this question as well. This was quite simple. In this, we just had to check if a string is a subsequence of another or not. So I just used an offhand solution for this. So what I did is I took an integer to update the indexes of the first word, and then I started a for loop for the subsequence. And in that for loop, if uh, I use a while loop which updates I if while the index size is less than the size of this word 1, and while the character is not equal to uh, the character in this word as of I. So I update I till then. If I becomes equal to size of the string, then we know that we have not found that character in the string, which means the subsequence doesn't exist, obviously. So we can just return false. Otherwise, we have found a match, so we can just update I and character is updated automatically. So for example, if we have found A and A, then we update both of them to the next position. In this case, the same thing happens, we update them to the next position, and if we have come out of this whole for loop, then we know that we have found the subsequence and we can just return true. Very simple solution, very simple question. Now we can just move on to the next question. Move all special characters. Okay, so we have solved this question as well quite quickly. In this, we just had to remove all of the special characters from the string. What I did is I created an iterator because passing an iterator to the erase function is easier and faster, kind of, whatever you want to call it. And then I just used a while loop. Uh, the condition for the while loop is it runs until the iterator does not become equals to s dot end, and then inside it I'm checking if it is not alpha numerical or if it is not equals to just a space. Then I erase the iterator, and then I continue. If I'm not erasing it, in that case I update the iterator to move forward one position. And if I'm removing, then I'm not moving forward one position because the character in the front is scooching back or like shifting backwards because we are removing the current character. So that is it, and the solution works fine. They have made a mistake in this test output here. Here they have shown it correctly because there should be two spaces. So my code works completely fine. Now we can move on to the next question. Okay, so we have quickly finished this question as well. This was very simple. We just had to count unique characters in two strings. Of course, I could have used. There are many ways of doing this one. I used a set, although we are doing kind of like string questions, so I am not in the mood to use other uh, STL collections, but I can't do much about it. This was the simplest way of solving it. I just used an unordered set. I just added the characters of both of these strings in the set and just printed out the length of this set. You could have used an unordered map as well, or anything else you might have wanted. This was the simplest way of solving it. We can move on to the next question now. Okay, so we have solved this question as well. This was very simple. We just had to count the duplicate characters in a string. What I did for this one is, by the way, it is only asking for duplicates. So if, for example, a t already exists and there is another t, then you will just be counting it as one. The first one won't be counted, only the duplicate will be counted. So, anyways, what I did, I used a set. I started putting characters in the set, and while putting the characters, I was also checking if that character already exists or not. If it already exists, then I just update duplicates by one, and if it doesn't exist, I just insert it in the set, and at the end I can just print out the number of duplicates. You could have also used a map. You could have just kept a count of the duplicates and just added them up by the end, but anyways, it doesn't matter. Now we can move on to the next question. Easy enough. Okay, so I have solved this question as well. In this question, we had to find the longest sequence of consecutive ones in a binary string. So, like there's a binary string, and we have to see what is the length of the longest sequence in which ones appear consecutively, or the longest sequence of only ones, you can say. So, for example, this is the longest sequence of one, this is the longest sequence of one. So in this case, it will be two. I used a sliding window approach for this. Very simple. I just used a starting index and ending index for the window. Obviously, this is for the window, and I ran it till end reached s dot size. So the condition for the while loop is while end is less than s dot size, and if s of end is equals to 1, then I just update end or move ahead by one position and just continue. And if it is not, then I check if the length of the current window, you can say, or current sequence of consecutive ones, if the length of that is greater than the longest sequence, then we just use the sub str function and pass in the starting index and the length that we need, which is end minus start, and then we just update end and put start equals to end as well. And after coming out of the loop, we use the same condition to update longest sequence once again, because for the very end we are at this position. Let me show you. Yeah, so we are at like this final position with end dot size. There is a possibility that we are here, and if in case we are here, which we most probably are, obviously we would be, then we just check if the longest current sequence is like greater than the previous longest sequence, and then we update it again, same condition and same logic, then we just print it out. Simple question. Now we can move on to the next one. Okay, so we have solved this question as well. In this question, we had to check if a string is titled case or not. What I did is I used a find function to find each space, and then I would extract the word using substr. Then I would check if the word is not empty or if it is not just a single space. Uh, if in case it is just empty or single space, I just update start to the next position and update pause to find the next space from the start, and then I continue. If it is not empty, then I check if the first character of the word is not is upper or not. If it is not, then I return false. Then I have written a function to check if the rest of the string is lower or not, and I just pass in the substring from the first position till the end, and if it is not lower, then I return false, and if it is true, then I just update start with position +1 and update position to find the next space accordingly. Then after coming out of the while loop, I do the same thing again, since pause can be ahead by one position and it might not be able to check it. So then I just run the same piece of code again, and if everything is correct, then I just return true and the code works completely fine. You can also add a condition to check if the word is alpha or not. For example, in this case they have given a full stop. I have not put a condition to check if it is alpha or not first, and you can do that if you want to. I don't really mind. Anyways, now we'll move on to the next question. We have solved this question as well. This was very simple. We just had to insert space before lowercase following uppercase. So basically in this sentence you just have to add spaces in between these words. The condition would be that the first one is going to be lower, the second one is going to be upper, then you add a space in between. In this case I have also not added a condition to check if it is alpha or not. You can do that if you want to. First I was feeling a bit lazy, so I just did not. Now we can move on to the next question. By the way, in problem 28, they are telling us to extract a specified number of vowels from a string. And the problem is their test case does not make sense considering what they are asking. So I just checked their extra test cases to see if it makes sense, and these make sense. You are extracting two vowels from this string, three vowels from this one, and I don't know what is wrong with them, but they are here. They have written if the number of specified vowels is less than the number of vowels present in the string, then you just print this statement, which is very weird. I'm going to avoid this. I'm just going to write a simple code to extract the number of vowels from it, and if the number of vowels present in the string is less than the number of vowels required by us, in that case I'm just going to uh, uh, print a statement that it's not possible. So yeah, that's it. Okay, this was very simple. We have solved this question as well. And in this case, what I did is I just iterated each character. I created a string of vowels, which will be storing the vowels that we are going to be getting. And whenever the vowel size becomes greater than equal to the number of vowels that we need, then we just break the loop. Otherwise, we have a separate character called check. So we convert C to lower for check because we just want to check if it is a vowel or not. We check these conditions. If it is any of these, then we just add C to vowels. I'm doing C to vowels because if it is an uppercase, I want to just add it as uppercase. And if that is not a requirement, you can just add check or whatever you want. And if after coming out of the loop, I'm just going to check if the size of vowels is less than n. In that case, we have not found enough number of variables. We are just enough number of vowels. In that case, we are just going to print this statement, and otherwise we just print the string vowels. That is it. Now we can move on to the next question. Okay, so we have solved this question as well. This was very simple. In this question, we had to just input a number, any number, it can be any integer, and we just had to comma separate it from the 1,000 positions. Basically, after each 3 digit, you just add a comma starting from right, or ones digit, you can say. So, what I did in this case, I had that number. I created a string in which I'm going to be adding the final output, and I created a count that was counting each time we are reaching 1,000. So uh, the while loop continues until n is greater than 0. We will be dividing it by 10 each time, so we run the while loop until it is greater than 0. And the first thing that we check in this, if 1,000 count becomes equals to 3, in that case we again reset it back to 0, and we add a comma in the string, and then we just continue. Otherwise we extract the rightmost digit, update 1,000 count variable, and we add that digit to the comma or the string that we have created, and then we update n as well by dividing it by 10. Final output is just the string that we have created. Simple question. We can move on to the next one. Okay, so we have solved this question as well. This was quite simple. In this case, we had to identify missing letter in a string sequence. So we just have a list of strings in order, as you can see this way, and we just had to check if there is a missing letter. The code is quite simple. I just ran a for loop till about the size of s minus 1, and for each character I'm checking if the next character is not the character just ahead of it using +1, and if it is, then I just return the character that is missing, and if it is not, I just return a space. So, and then I just print out the answer accordingly. That's it. Now we can move on to the next question. Okay, so we have solved this question as well, 31st. In this question, we just had to check if a string contains only uppercase or lowercase letters. I just created two separate functions for each. One checks for if all of the characters in the strings are lower or not. Other will check if all of the characters in the string are upper or not. And if it is neither of these two cases, basically neither all characters are lower, neither all of them are upper, in that case we will just print false, otherwise we will print true. So this was simple enough, and now we can move on to the next question. So we have solved this question as well. In this one, we had to reverse all of the words whose length is greater than equal to 3 uh, in the string. So what I did is I just started a while loop, and I had a start variable and position, which gives me the position of the next space. So what I do is I just check position minus start. If it is greater than equal to 3, then I just reverse by sending the address of the start and the ending position, then update the start and I update pos accordingly. After coming out of the while loop, we know that position is probably ahead of uh, basically after the last character of the string. So in that case, instead of using pos, because it will be a garbage value, it will be pointing randomly quite far ahead. So what we are going to do, we are just going to check if s of size minus start, which is the end position, is greater than equal to 3 or not. If it is greater than equal to 3, then we just reverse like this, the pointer of the starting position and the address of s dot size. Then we just print out the string, and that is it. So very simple question, very simple solution. Now we can move on to the next one. Okay, so we have solved this question as well. In this question, we had to check if the letters of one string appear in the other one or not. So we had to check if the letters in the second string appear in the first one or not. And this one did not specify if we needed to keep a count of that as well, like same number of characters should appear or something. You can't just check the copy. For example, if there are 2p and we assume there are two p, then we check one p with one and another with another. If they wanted something like that, we could have used a map, but in this case we did not need that. At least I assume we did not need it. It's not mentioned anywhere. And the letters are case sensitive, it is mentioned, so I just used a very simple for loop on the second string, got each character, just use the find function in the first string to see if that character exists or not. If it doesn't exist, I just straight up return false, otherwise I return true. This strategy works because even if it is case sensitive, it will work completely fine. So this is the solution. Now we can move on to the next question. Okay, so we have solved this question as well. I was making a mistake in the erase function in this. I thought it would have worked just like any other function in which we had to pass iterators of both the locations that we are trying to engage with. But instead, we had to pass the starting position and the length that we are trying to erase. So that was my mistake. And the solution to this is very simple. You just use the dot find function to see if this exists in this or not. If it does exist, then you just take the position that you found of this and delete till about its length, and that is your answer. Very simple question, very simple solution. We can move on to the next one now. Okay, so we have solved this question as well. This was very simple. We just had to reverse the words of word length in the string. So what I did, I just started a while loop to find each of the words with starting index 0 and position of each space. The loop runs till the position does not become equals to n post. And if position minus start, which is the length of the word, is not divisible by 2, then in that case it is odd length. So if modulus 2 does not return 0, it is odd. We just use the reverse function with the iterators of both of the position, starting position and the ending position of the word, and then we update start, we update pause, and after coming out of the loop we check the same thing but with s of size, since pause will be some random garbage value quite up ahead. So s.size minus start. If it's not equals to 0, you reverse and you just print it out. The output is fine as well. Now we can move on to the next question. So this question was a bit too simple. You just had to check if two consecutive letters are identical or not. So first I just checked if the size of the string is less than equal to 1 or not, because if there is only one character or no character, there can't be two consecutive identical characters. In that case we just return false, and otherwise we start a loop from 0 till as of size minus 1, and we check with the current index and the next index if they are both equal. If we find even a single case of that, then we just return true, otherwise we return false. So these test cases work fine as well. Now we can move on to the next question. So we have solved this question as well. In this one, we just had to count the occurrences of a specific character in a string. So for example, in exercises, we had to see how many times E appears. So it appears 2 times in it, 1 and 2. So for this, I just used the count function from STL. In this, I was making one mistake, that I was just passing S1 as it is, which is a string, but it won't be able to count a whole string, how many times a whole string appears in it. So with count function, you have to use a character. So I just passed in the first one because I know we are only passing one character. But in case you need to use a string, you need to find the occurrences of a string, you just use the find function in that case. Just use the find function until you hit end pose. That's it. Now we can move on to the next question. So we have solved this question as well. We just had to remove a specific character from the string. So I don't remember if there is a function like remove that we can use to erase all instances of a specific character. So I just used the find function. So I find that specific character that we have to remove, and if we have found it, then I just remove from that position erase of size 1 that particular character, and then I find the next instance of it and continue until I have it and pause. So that's it. Let me check if there is actually a function to remove all instances of a character. Remove function, okay. I did not know that. So remove as will begin till n, till s of n. This removes all occurrences of that character. Makes sense, I use this method basically. You can use whatever you want. Now we can move on to the next question. Okay, so we have solved this question as well. We had to check if the string contains only unique characters or not. So what I'm doing in this is I'm using an unordered set. I create the set of that string, the characters of the string, uh, by passing the iterators of it in the constructor, and then I just check if the size of these two is equal or not. Because if the characters are not unique, then the size of the set is going to be lesser than the string. And in it I was making one mistake, that I wasn't passing the type of set. I don't know, I just keep making that mistake with sets. Hopefully I am able to learn from my mistakes and correct it in future. Anyways, we can move on to the next question now. Okay, so we have solved this question as well. Very simple. What we had to do in this is, in the first string, we had to check all of the characters that are lowercase, and in the second string, we had to extract the characters which are at the same position as those lowercase characters in the first string. So, for example, in the first string, we check the first character that is lowercase, which is A. The position is 1. So, in the second string, we are going to check the character that is at position 1, and we are going to add it to another string. Similarly, with V, we get C, with A, we get R, and then we extract these, and this is the output. Similarly, in the next case, you can see uh, J is lowercase, so we get capital J for the next one. And S is uppercase, so we ignore the next character in the second string. And then C is lowercase, so we extract A as well, and we get JVA. So what I did is I just created a string answer. I ran the loop until the index is less than size of both of the strings in this case, because the number of characters that we can have will always be less than equal to the size of the smaller string. So whichever one is smaller, we just check the size, and it should be smaller than both of them. So if it is lowercase, we append the element at the same index in the other string to the answer, and then we just print the answer out. It's a very simple question. Now we can move on to the next one. Okay, so we have solved this one as well. In this question, we had to find the position of the second occurrence of the other string. So we have to find the position, for example qu. In this case, we have to find the position of this qu of the second occurrence of this qu. So it appears first at what is this, 4, 0, 1, 2, 3, 4, and the second one is at 7. So yeah, we just need to return that. And the code that I wrote for this is that I'm keeping a count. So I again use the find function position, and if position becomes equal to npos, then I break the loop. And in the while loop I check if the count is equals to 1, because if it is 1, then it means we have already previously found position an occurrence of this substring in the original string, and now we have found the second one. So we just return pos in that case, which is the position of the second occurrence, and otherwise you just update count and try finding the second position. If you have not found the second position, which means there is only one occurrence of the substring in the original string, in that case you just return -1. So now we can move on to the next question. So we have solved this question as well. We had to alternate the case of each letter, with the first starting letter being lowercase. So very simple question. We just checked if the current index is divisible by 2 or not. So if it is even index, in that case we make it lower. If it is upper index, then we make it if it is odd index, then we make it uppercase. That is it. Very simple. And with this we have completed all of these questions from W3 resource on strings, and you can practice a few more questions if you want somewhere else, or these ones. I will leave a link to these sets of questions in the description, and that is it. Have a good day, and
so please whatever, please I want to reach 1 million likes. So please okay, thank you.